So go ahead and fill in the diagram on page 3 with the following words: rational numbers, whole numbers, natural numbers, integers. And if you can, provide examples for each category of number. I'd recommend doing it in pencil just in case I end up correcting you. Or you can just not write anything at all and think about it. So try to think, where should those words go, which group fits inside the other groups, and what are some examples for these groups of numbers. Okay, ready to go? This is your smallest circle. What did you write in your smallest circle, or think to write in your smallest circle?
Integers?
Not integers.
Natural numbers.
These are the natural numbers. Natural numbers. And the natural numbers include all positive whole numbers. So you can write that. That tells you start at 1 and you count on and you'll get all the natural numbers. No fractions, no decimals, no halves, no zero, no negative number. All right, the group of numbers that is slightly larger than the natural numbers is what group?
Rational numbers. Integers.
They are the whole numbers. The whole numbers, they include all of the natural numbers. 1, 2, 3, ... They also include 0. You'll notice I often put a slash through my zeros. It's so that they don't look like O's. I also put a line through my Z so that it doesn't look like a 2. Good. Next group of numbers includes the natural numbers and the whole numbers and a bit more.
Rational.
They are the integers. Now, integers include all the whole numbers, so from, and I'll just start over here, and the negative numbers, but only whole numbers. No decimals, no fractions, but you've got from -3, and actually there should be a ... in front of there. 2, 3, ... Goes forever and ever, both ways, to negative infinity and positive infinity and 0, using only whole numbers. And the last circle that you have there are the rational numbers. Rational numbers. And you're going to write really small in the rational number part. Sorry, I should have told you that before you started writing. But you're going to want to write pretty small, because in the rational numbers, I'm not just going to write examples, I'm going to write a little definition, because we're going to get to this a little bit later. But a rational number is any number. This little, the hashtag, it's represents a number, okay? Number that can be expressed as a fraction using integers. So it can be a fraction using integers. So that means some of the examples could be 1/2. 1/2 is a rational number because it's a fraction using integers. Okay, there's an integer on the top, integer on the bottom, numerator, denominator. The thing together is called the quotient. Quotient is a half. Okay, the numerator is a whole number, the denominator is a whole number, the quotient is a rational number. Another example, who can give another example of any fraction using integers?
3/4.
We could do 3/4, and I'm going to switch it up. I'm going to do -3/4 because integers can be negative as well. Any other examples? What about 0.65? Can that be represented as a fraction using only integers? No.
Yeah. 65 over 100.
65 over 100, or 13 over 20. So 0.65 is also a rational number because it can be expressed as a fraction using integers. Okay? What about 0.02? Okay, so this would be 2 over 100, 0.02, and we could even, just for the sake of an example, throw a negative sign in front of that. These are not all the numbers in the world. There are also irrational numbers. Okay, those are numbers that can't be expressed as a fraction. So for instance, the square root of 3, you can't represent that as a fraction using rational numbers, using integers. There's also imaginary numbers. We'll get into that later. Probably, I don't even know if we cover that in grade 9, but grade 10 for sure. So, a little definition for integers there under the ovals of number groups. Integers is the group of numbers that includes, we're going to start with the biggest kind of definition we can think of, all whole numbers. And then we're going to qualify that statement, all whole numbers, including 0, positive values, and negative values. And again, you have some examples up above in what we did there. For the next part, you have a number line, and it's going to be an integer number line. You can underline the word integer in that sentence if you like to keep yourself organized, and basically you're going to create it. And what do you need to include on an integer number line?
A 0.
You got to put a 0 somewhere, so go ahead and put a 0 somewhere and fill in the rest. Don't put your 0 all the way on the left. Put it somewhere in the middle-ish, and go for it. Okay, your number line should look something like this, and we're going to use our number line now just to dive into a few simple problems involving integers, basically just relating greater, less than, or equal to, and you know those symbols that you're able to choose from are going to be the greater than symbol, right? Here, x is greater than y because the alligator, the y, is eating the x. Nope. Yeah, the alligator's eating the bigger thing. Yeah, there we go. Oh boy. Okay, we have x is less than y, and here we have x is equal to y. Okay, those are your three options: greater than, less than, equal to, and basically you have your numbers there. You have 12 and 8, and all you need to do is put the alligator facing the right way. Of course, he's hungry today. He's going to eat the 8. Go ahead and Sorry, he's going to eat the 12. Should re-record that, eh? He's going to eat the 12. And go ahead and do the next two there as well. But be careful, use your number line when you're thinking about negative numbers. Which number is actually greater between negative 18 and negative 15? Which number actually has a greater value?
Negative 15.
Negative 15 has the greater value. So go ahead and draw your caret. Your greater than symbol should be opening toward negative 15 on that one.
An alligator.
Caret, yeah, caret goes up like that. Caret is shift 6. After that, the last thing we need to do with our introduction to integers in lesson 1.1 is to convert the following words to numbers and symbols. So we're going to make a greater than, less than, or equal statement using the information in that sentence. And go ahead and try and do it on your own. It's positive 4 is greater than negative 1. And your response should look like this. And at the bottom of your notes, you have some practice problems to do. There are loads of practice problems, but they're quick and they're integers, right? It's basic stuff about integers and number lines, etc. So work through them efficiently, as in keep going, but also be careful. Don't let the negative signs trick you, okay? They're listed on the bottom of your page there. They're from your textbook, page 50. You're going to do numbers 1 through 6. Numbers 12 through 45, numbers 53 through 74, and number 90. Enjoy.